Welcome everyone to the UC San Diego Database Seminar. My name is Arun Kumar. Today we have an awesome speaker from the data management industry, Juan Sequeda. I hope I'm pronouncing your name right. And he's going to be talking to us about knowledge graphs and real-world data management challenges and why they are also a people problem. Just a protocol for the seminar talk. The audience, if you have any questions, please raise your hand, and then I will interrupt the speaker, and then he can answer the questions. Short questions, clarifications, we can do it during the talk while he's speaking. Longer discussions, we can keep till the end of his talk. And just to recap, this talk is being recorded, so you will all be recorded, and if you're asking questions, that will be recorded too, and it will be posted publicly on YouTube. Based on Juan's wishes. Okay, so with that, let me turn it over to Juan. He has done some spectacular work in the space of knowledge graphs. This bio is too long, and it'll take me several minutes to speak it out. So at this point, I'll hand it over to Juan. Juan, take it away.
Great. Thank you, Arun, so much for the opportunity. And I'm just going to jump in. So this is what keeps me up at night, is how do we get from today's application-centric databases, these databases that are built and designed to support applications, meaning that they are enterprise applications, which are thousands of tables and tens of thousands of columns. So how do we get from this application-centric databases to what we call a data-centric view of data? The data is actually meaningful, it's understandable, to something that, frankly, if anybody can look at this data, it actually makes sense. Instead of looking at a database that you're seeing right here, a database of thousands of tables, you want to be able to look at data and understand that. But the question is, how do we get from that inscrutable enterprise data to this meaningful view of data by taking into account the people in an organization? That's a big question, and that's what I'm going to be talking about in this talk. So the title of my talk is the Socio-Technical Phenomenons of Data Integration and Knowledge Graphs. So a little bit about me. I carry two hats. I carry my academic scientific hat. I did my PhD in computer science from the University of Texas at Austin. My research has been on the integration, understanding the relationship between relational databases and all the semantic web, graph databases, and now knowledge graph technologies. So essentially on the intersection of logic and data. And one of the deliverables for my research and my PhD was a system, in addition to all the theory, on how to virtualize relational databases as if they were semantic web databases. And I also carry my industry academic hat. My industry hat, which is I'm principal scientist at Data.World, and for my research, we founded a company called Capsenta with my PhD advisor, Dan Maranker. And that was a company that we did to go commercialize our research and to be able to do data integration. We were acquired by Data.World last year. And inside of what Capsenta we were doing, we were developing a lot of tools to be able to take knowledge graphs and commercialize them. So kind of with my industry hat on, I do technical sales, but one of the things that I like to do is that I like to get to talk to customers and understand their real pain points, the real problems that they have. Understand what is science, understand what is engineering, and if you do identify problems that could be science, how can we translate them back and kind of have this closed loop? And over the years, I feel that I'm trying to build these bridges between academia and industry. So I've been a part of industry standards. There's a W3C standard on mapping relational databases to RDF graphs. That's almost 8 years old. The work on that started over a decade ago. I'm the editor of one of those standards. The LDBC had, several years ago, we had this query task force to develop a query language for property graphs. And out of that came a language called GCore, which influenced this new ISO standard called GQL. And right now I'm the co-chair of the community, the LDBC Property Graph Schema Working Group. So always trying to balance academia and industry. I find it very, very important to have this loop. So just a little bit about where I come from Data.World. I'm excited about being at Data.World. One, we are an enterprise data catalog. So we do metadata management, data management. We have a lot of really cool data virtualization, federation technology. We're all built on knowledge graphs and all that. But what's really cool is that we are a public benefit corporation. We're a B Corp. So in addition to maximizing shareholder value, which is what you want to do as a company, is that we have a public benefit mission, which means that we want to build the world's most meaningful, abundant, collaborative data resource. We advocate for open data and linked data standards. So we actually are the world's largest open data catalog. So we have over 500,000 data sets and over 1 million users. And so this is a lot of the learnings that we also get from our community. So with that quick intro about me and Data.World, this is the takeaway. So in case you need to leave in the next couple minutes, this is what this talk is about, what I want you to take away. We have been studying the phenomenon of data integration from a technical perspective. And my thesis is that we have been ignoring the social aspects of data integration. So the big question I ask myself, and what I'm asking myself throughout this talk is, how do we generate this meaningful, understandable data from complex enterprise data? And the quick answer is that we really need to understand how to combine people, processes, and tools together. And that's what I'm going to go into a little bit more detail in my talk. So I will give a caveat that this is not a pure scientific talk. So I'm presenting this from an industry perspective, but I do want you to leave with some ideas, and I will be presenting those ideas. So what is data integration? So if we go back in history, I think a lot of the work in data integration started around the 90s, like the active work around the 90s, all the big projects. I mean, T. Simmons in Stanford, right? InfoSleuth, SIMS, and at USC and so forth. During the early 2000s, I think the academics, the database theoreticians started to get involved. And this is Mauricio Lencerini's seminal paper at PODS, where they're starting to now understand data integration from a theoretical perspective. And I really love this definition, right? Data integration is the problem of combining data, reciting at different sources, and providing the user with a unified view of this data. And over the years, over the last 2 decades, we've been tackling all these really hard problems of schema matching, ontology matching, record linkage, instance matching, entity linking, has so many different names, dealing with incomplete data, data quality, materialization, virtualization, and so forth. And the elements of data integration are, well, you have a global schema or a target schema or an ontology, right? You have the global view. You have the source databases that have their source schema, and you're defining these mappings from source to target. Now, what I find fascinating about this definition is that even in the definition, you have this term called user. But actually, it's super interesting that we really don't focus on the user. If you look at, as a community, we haven't focused on the user over the last couple decades. So let's look into this problem of the enterprise data integration problem. So that's one of the takeaways I want you to have is understand the real world problem here. The real world problem, let's start, remember those 3 elements, the source, the target, and the mappings. Talk about the source. Real world enterprise databases. This is actually 1/4 of one database schema of a database I've worked with the customer. So what are the problems that you immediately see? What are the things that we observe? There's too many tables and too many attributes, right? We're talking thousands of tables. If you work with systems like an Oracle e-business suites or a NetSuites or an SAP system, you're talking about 25,000 tables. And imagine the number of attributes. I mean, this is the type of schemas that you're working with. The namings are almost impossible to understand. So you in your traditional textbook, your database textbook, you have a table called order, right? I'm going to use a lot of retail e-commerce examples. Order, customer, order line or line item. What you think in an order management system, there's going to be one table called order or one table called customer? No, there's going to be so many of them. And sometimes if you work with systems like SAP, those names are probably even in German and you don't even understand them. The column names are sometimes, because you want them to be flexible, they're called segment 1, segment 2, segment 99. What the heck does segment 1 and segment 2 actually mean? To get the relationships are defined there in a complex manner. So you would think, oh, let me go find all the orders and the customers that place those orders. And you would say, oh, there should be a table called order and a table called customer. I should just join that. No, to get that simple query, what all the orders and their customers, it can be a very complex set of joins across all these different tables. Why? because the databases are application-centric. So this database has been modeled to represent the needs of the application. That's why it can be horizontally partitioned, it can be vertically partitioned. We need to go optimize for our query workload. So that's why we need to go separate customer data all over the place, or we're going to have an application that's going to be very flexible, that therefore we're going to support an EAV, an entity attribute value model for the data. All these types of things happen in the database. Now, who understands this database within our organization? There's definitely people who may understand it, but they're probably very, very busy. They're unavailable. So how do you get time to go talk to the people who know this database? Now you would expect maybe there's documentation. Well, first of all, if there is documentation, it's probably out of date, but most probably documentation doesn't even exist. So you don't even know how to start from here. Now, sometimes you're actually looking at data from a database, but you're not accessing the raw database. You're getting a dump of the data. And that dump can be a dump of a table that can be shown to you in a CSV file, in a spreadsheet, or it can be a dump of a query. So you actually don't know where that data is. And then frankly, the other issue is that you don't even know what is the quality of the data, how much you can trust the data, right? You see there is a null value in that database. What is that null supposed to mean, right? How do you know what is the quality and can you trust this? And all these issues happen, and we're just talking about one particular database. Imagine we start going to multiple databases. So these are I'm sharing with you observations of the real world in these large enterprise databases. So let's go talk about the target. So first of all, there is over the last couple decades, there's all these methodologies to go develop these conceptual models, these domain ontologies, and they're driven by competency questions, and there's test-driven development and design patterns and everything. They're very sophisticated to go use. And then a lot of industries develop their own conceptual models, right? Or their own upper ontologies. So insurance has something called Accord. Healthcare has something called FIRE. Finance lately they developed something called FIBO, the Finance Industry Business Ontology, et cetera, et cetera. So, and the idea is that you should go off and reuse the existing conceptual models. But these things are so big and so complex that when people go and see them, they're so confused that they probably use them as an inspiration or something, and then they go off and do their own thing. And then what happens is that creating this target model, creating your global schema, your target ontology, there's all these methodologies that go help you create them. But actually, the thought of populating the target from the source is an afterthought, and it's not part of the methodologies. And what we see all the time is that when people are starting to go integrate data and they're going to create their target schema, they boil the ocean, which means that they say, well, we got to go integrate all these databases, right? I get all the databases, let's go all the requirements, and let's go build this target schema first. And let's go create this, and then we're going to go map and put the data in there. So they end up boiling the ocean, getting all these requirements first, and want to go implement the model for it. At the end, having this target model by itself is meaningless because you need to go populate it. So that's one of the big issues that we see. Now, a third problem we see is the mappings, the source to target. Now, this is something that I honestly I was pretty naive when I went off kind of in the real world. A lot of my work was under the assumption that these mappings would be created automatically, right? Because there's all this work on ontology matching, on schema matching. And frankly, what I saw was I got my hands on every single ontology schema matching tool that I can get, that I can take as input a source and a target. And the output, things worked in theory in all your test examples. But when you took in a source database that had thousands of tables, and you started creating this target schema, which obviously was going to be much smaller, the output was useless. So, and why is this? Because a lot of the work that has been done in this area has been to automate and assuming that you're always doing a one-to-one correspondence. Oh, there's this table here, and there's this concept here. Let's call it order. A table called order is mapped to a concept order. Right? Or maybe you would do, oh, there's F name in the source and I have first name and L name and last name. Oh, probably F name means first name and so forth. Those types of mappings are actually pretty rare in practice. What you see in reality is that you have tables that can have the word order in them. You can have tens of different tables that have the word order in them. So if you go apply all these techniques, then suddenly all these tables that happen to have the word order in them gets matched to this concept called order. That doesn't mean anything. The majority of this was actually really interesting work that I've seen before, that people analyzing all these systems, and basically the majority of them use a bunch of string matching. That's it. Maybe then they use a little bit of structural. Then you have columns like this. You have columns that are called segment 1, segment 2. And then people say, okay, well, let's go use the values, right? Well, the value says A, B, and C. What does segment 1 mean when the values are A, B, and C? Right? These are the real world problems. So I'm going to stand up and make a very bold claim right now and say that I don't believe we're going to automate this. I think this is an AI complete problem. And the reason why I'm saying this is that if we're going to go automate and use machine learning, we need a lot of data to go train and everything. We got a lot of data to go do kind of at the instance level, right? I want to know if Bob Smith is the same thing as Robert Smith. But at the metadata level, getting a lot of schemas and mappings, we don't have a lot of them. So it's going to be really, really, really hard to figure out how to go automate this. So I don't think, so for me, I'm starting in the position that I don't think we can go automate this. We're going to have to start from a different position. So another problem that we see now that we understand the kind of these technical aspects on the source, the target, the mappings, is the social aspect. And a glimpse of the social aspect is what I call the knowledge hoarding threat. So people are involved and they know about what's going on with an organization. They may understand exactly how things are defined. And in reality, when people have this knowledge is power, and they have job security. They don't want to give up this power. And this is one of the big problems that we see all the time. And I tell, imagine you have a magic wand, and the magic wand can you have the perfect tools to go do this, but you still need the people to confirm what these things actually mean. And they feel threatened to say, oh, wait, everybody comes to me for help. And you want to democratize data and make things self-service, that means that you don't want me to go do my job. So the people who have this interest, have all this important knowledge in their head, they don't want to go share it. So this is one of the big social aspects, the psychological aspects actually, to go do. This is what I call the knowledge hoarding threat. But let me step back for a second and ask, why do we integrate data? Fundamentally, why do we do this? So I think that we have been defining success from a technical perspective, and which means our goal is to physically put data in one place, right? Integrate them all with the schema and everything. And once the data is integrated in a place, we call it success and we're done. And that's why companies will go they'll hire other big companies like an Accenture, whatever. They will spend 6 months and $1 million to go integrate data. And then they put it all together in a data lake and then they say, we're done. But no, you're not done. Because in reality, why do you integrate data? You integrate data to go answer questions, to go answer business questions. And I believe that success should be defined if you're able to go answer those questions. So if you put the data all in one place, but your end users are still not able to go answer the questions that they're tasked to, then you're not being successful. Data integration is a means to an end. It is not the end goal. So this is the real world problems are the following. A business user wants to go ask a question, how many orders were placed last month? Well, they'll go ask the e-commerce folks, the people who manage the website and everything, they get one number. They go ask the shipping folks and they get a different number. They go ask the finance folks, they get a different number. Same simple question, and they ask different people, they get different answers. Why? Well, frankly, what do they mean by an order? This is the problem. So for the e-commerce, when you use the word order, for me, it means when somebody clicked order or checkout on the website. For the shipping folks, it means, oh, the package was delivered. For the finance folks is no, when the money came into the system. So technically everybody's right, but at the same time, everybody's wrong, depending on the context. So this is where the semantics come in. Like we have one word that can mean multiple things, or the other way around. I can use 3 different words, but they all mean the same thing. So let's look at this people aspect. So if we look at within an organization, there's one camp of folks who are the data producers. Their titles like data engineers or data stewards. They're the folks who understand the databases, how the data is connected. They're the ones who will create ETL pipelines that will put things, that will move the data. Then you have also on the other side, the data consumers. And they're your data analysts, they're the data scientists. They're the folks who need to go answer these critical business questions, and they understand how the business works and understand what the priority of these questions. What happens right now is that we have this big gap in the middle. So all this work happens, but nobody's taking responsibility of the actual data. And I argue, so what actually happens within this whole process? So you have these data consumers and these data producers. What's the current process? So a first approach is what I call the spreadsheet approach, is that a data analyst needs to go answer a question, and they're gonna go ask the data engineer. I need to answer this question. The data engineer says, okay, I'll get you the data. They look at the database, but they're kind of confused. They're not really certain what the table they should use and whatever. They need to go talk to the data architect. And the data architect is one of those people who are super, super busy, and they won't get a message. They got to wait hours or if not days. Finally, they have the conversation. They figure out what it is, and they write the SQL query that needs to get the data, and voila. They send a CSV file or a spreadsheet back to the data analyst. The data analyst now takes that up, probably opens it up in Excel, does something, and sends a report back to their boss, the executive who's asking that question. But that data analyst is probably continuing doing this exact same cycle with different people. Or they need to get a new version of that data, and they have to go ask the data engineer again, and they send the new spreadsheet to the data analyst. At some point, the data analyst is now filled with a bunch of spreadsheets. And actually, it's pretty cool you can do in Excel, right? You can take Excel and kind of open and point from one Excel file to another Excel file, basically doing like foreign keys between Excel files. And that's why if you've opened a complicated Excel file, it won't open up, is because you're missing all these files. Now, a data analyst who's probably a bit more technical savvy will have an Access database on their laptop, and they can probably they can load the database, the spreadsheets into the database. They do God knows what kind of type of munging, and the reports come out. The questions here. Did the data analyst actually communicate the right message to that data engineer? And did the data engineer actually get the correct data out there? Do we really know this? I don't know. So then let's go to a next approach, which I call the query approach. So now that data analyst who's asking that question to the data engineer all the time, the data engineer says, I'm sorry, I'm just clicking a button here for you. I'm going to give you read-only access to the database, and here's this query that was running. You can execute it however you want. So the data analyst says, well, perfect, I can go do that. And then suddenly they get one query from one person, they get another query from another person, and if they're a bit technically savvy, they can say, well, this one query returns a table. I can put that in a one big from clause. Here's another query, I can put in another from clause, and I can join that together, and suddenly queries started getting bigger and bigger. I have seen queries that are 10, 15 pages long. They will run in 10 minutes, and they will give you the data back, and they send that data back to the executives to go make decisions on a $1 billion company. Do people actually know what goes on in these queries? I mean, this is actually a real world snippet of a query that I've seen that a customer has. If you look at this query, look at all those left outer joins. Why are there left outer joins, first of all? Look at all this hard coded values. You can see there's a 0.15 times is null, 0.35. Why are they doing that? Do we actually know? And here's a real world anecdote. We were analyzing a lot of the queries people were doing, and when I explained to them what we did, because basically I reversed engineer what these queries were doing, they were like, wow, it's not zero, it was 0.15 because it was some discount we were giving, and we're not giving that discount anymore. And I'm like, well, go figure. All the numbers you've been doing for last year are completely wrong. So after this is when you realize, well, no, we need to have a data warehouse. We need to have one single place where we can have all our data pushed, right, centralized, and we can go query that together. And that's when you'll go call an Accenture, right? All these companies will go in and you go hire them to go build your enterprise data warehouse, and they'll go do all these requirements, and they'll bring in all this data, all these engineers to go do all this development of ETLs, and this stuff is what takes 6 months and $1 million. They go do all this work, and then suddenly say, okay, Now let's stop doing our ad hoc process. We got our data in our data warehouse. We can go query this all together. And at that point, the data analyst will say, oh, you know what? We forgot to give you some requirements. We forgot to give you, we also need some other information, and without it, we can't do this work. So then you go off and say, okay, we need to go make these changes. Wait, let's go, we need to go add this new data source. The schema changes. That means that we need to go change the ETL scripts that we did before. Oh, by the way, the person who wrote the ETL script before is not at the company, so somebody else needs to go reverse engineer somebody else's code, yada, yada, yada. All of this continues. But what happens is that during this time, the data analyst is still solving their problem in their ad hoc way. You let it be the spreadsheet approach or that query approach. At that time, they're going to go compare the same answer, the same question. They're going to compare the question with their ad hoc approach, and they're going to compare the answer to the question that comes from the data warehouse. Do you think the answers are going to be the same? No. What are they going to go trust? They're going to go trust the process that they control. So they don't end up using the data warehouse. And that is the reason why data warehouses, quote unquote, fail. They don't fail for technical reasons. They fail for social reasons because people don't use the data after I've invested so much time. Now we think about, oh, and by the way, this is the problem of boiling the ocean, right? I'm trying to go create this one thing and taking all this time instead of figuring out how to go do this in an agile approach. Now, data lakes really just flips around ETL to ELT, right? Let me just go dump everything because somehow we thought that if we physically put all the data in one place, life was going to be good. Honestly, not really. It's the same approach. So now the latest thing is about data wrangling, right? Data prep, and now self-service, right? Because I have to go work with these IT folks, and they're going to go let me, I'm going to be very, there's going to be all these bottlenecks. So I need to be able to go do my work on my own. So the data analyst now has a data prep tool, and they can go do all their analysis on their own and generate the reports. Perfect. Another analyst does it, and they have to go prep some data across other systems, but also they share the system that somebody else has prepped, and so forth. Do we know that the way people are prepping the data across the same system, different people, they're prepping them the same way? First. Second, how much wheels are being reinvented? How much prep work is being done? True story. We had a customer talking about reports on what they defined as large orders. Well, guess what? Nobody defined what was a large order, and everybody prepped the data differently. A large order is if there were 5 things in the basket. A large orders if there were 10, 15. So then when they all started talking about large orders, their numbers were completely off. Well, of course, because nobody defined the semantics, the meaning of large orders. This work was not shared. Okay. I can keep going with more examples, but what I want the takeaway here is sharing you the real world pains that people go through. We have these tools, right? We got data warehouses, we got data prep stuff, but we still encounter these issues. So what? The thing is that there is this big gap between the producers and the consumers, and this is what I'm calling this data meaning gap. And the thesis is clear. If we don't bridge this gap, it's going to be garbage in and garbage out. Any analysis we're going to be doing, we won't be able to trust it. So we really need to understand, how do we bridge this data meaning gap between producers and consumers? So as you can imagine, kind of where I'm going with this is that this knowledge graph is a way to go bridge the gap. But obviously, the levels and the details, and we really need to understand this social technical phenomenon, which is people, methodologies, and tools. So I'm bringing up knowledge graphs here for the first time. And I'm going to provide you my informal, inclusive, non-pedantic, and non-scientific definition. It's when you're doing data integration and when you want your real-world concepts and relationships to be first-class citizens in your model. And when you combine these two things, what you're doing is that you're really integrating knowledge and data at scale. And this happens to be in a data model, which is a graph. So I always make a parenthesis here. Almost 2 years now, we had a dog stool workshop on knowledge graphs. I always tell students, if you don't know about dog stool, go to this dog stool website. It's basically the place where computer scientists get together literally every week there's a seminar on some particular topic where around 40 people are getting together to talk about the future about a research area. So if you want to understand what's the latest thing people are thinking about, just go mine Dogstool, because every single seminar will write reports, and you can literally see what people are thinking about the future. So if you're looking for ideas, just go to the Dogstool website, see every seminar in the past and what people are planning over the next 2 years. So one of the things that came out of this this seminar, we wrote this was really nice tutorial paper in knowledge graphs. We have it on archive. It's in the process of being reviewed right now in the ACM survey. This is like a 100-page tutorial page on knowledge graphs. So if you want to go dive in deeper into this, I highly recommend you to take a look at this. So I want to start with this preface. This is a fantastic book. I highly recommend. Professor Joel Kane, I think he's from Boston University. He has this book called The Technology Fallacy. And what is a technology fallacy? It's a mistaken belief that just because business challenges are caused by technology, that they also need to be solved by technology. And I think this is the fallacy that we always have, that there's a problem that was caused by tech, we need to go solve it by tech. And I think this is the switch that we need to start doing. I think we need to understand that people are key to this any type of transformation that we're doing right now. So let's talk about people, processes, and tools. So I've kind of explained the real world problem up to now, and I'm going to share with you how I'm seeing we can go address these problems today. So let's go start with people. So remember I talked about these two different groups, right, of the data producers and the data consumers, and then there's this gap between them. So first of all, I think that we need to fill this gap with something that I'm calling the data product manager, or data product management team. This team here, they're the ones who are actually going to be responsible for the data. They're going to be the ones who serve as this communication bridge between the consumers of data and the producers of data. So if you think about it, like software, we know how to go build software. We know how to build a team. What are the tools, right? If I'm going to go build a team, I need the software engineers, right? I need people who do QA and testing. I need a product manager. And the product manager is a person in that role who communicates the requirements and translates them to the software engineers. Part of that work that we do is this role that I call the knowledge scientist. I'm going to talk about it in a second, but I think the knowledge scientist is somebody who is going to be doing the knowledge work. And I think the knowledge work means I need to be able to communicate a lot with the consumers of data, and I need to be able to communicate with those producers of data. So that means that with the business folks, I need to be able to understand what they're doing and model their business, but I need to go talk to the data folks and be able and understand how to access data and go query data in it. And from a social perspective, I need to be a people person with the business folks, but I need to be able to be geeks with the data folks. So you may be thinking, wait, how does this relate with the data scientist, right? We always hear this 80-20 rule, right? The data scientist spends 80% of their time cleaning the data and so forth. That 80% of the data, that it's what we call quote unquote clean data or data janitorial work. That's the fundamental work that a knowledge scientist should be doing. And this is the work that it's truly knowledge work. It's not about cleaning the data that, oh, there's extra zeros or commas or whatever. It's understanding what these concepts mean, what the business or what the end users think about them and where they are in the data and documenting about this. I think they're the ones who are going to be responsible for the data. And I use the term scientists here on purpose. I believe that that knowledge scientists are the folks who will sit down and they observe. If they follow the scientific method, they will be making observations and talking to people, interviewing people, and they're understanding, oh, I'm observing that these terms are not well defined, and what could they mean? And let's go investigate that. And I'm going to go come up with hypotheses and say, I think it could either mean this or this. I don't know. Let's go find data to support it, and let's go see how I can find evidence to support which one is the right definition. So I think the knowledge scientists are the ones who are going to be responsible for this type of work. So how would you know if you're a knowledge scientist? And I've done this test with many people who are data scientists, and they realize that they're not data scientists, they're knowledge scientists. If you're the person within an organization who leads all these conversations to understand what are people actually trying to go do with the data? What are their pain points? Do you debate with people the definitions of terms? What is a customer? Are you the person who works with others and to understand what they mean, you go off on the whiteboard and you try to draw the schemas of what people are talking about, right? Do people come to you asking about, where is this data? Like, I need to go find this data for this thing that I'm trying to solve, and they come to you for it, right? Do you find yourself in the middle conversations between the IT, the technical folks, and the business folks, and you're the one who's trying to kind of get them to communicate better? Do you maintain a data catalog? Do you negotiate with the data owners? Are you the person who actually wrangles and cleans the data because you understand what this stuff means? Do you source the data for machine learning applications? Do you feel responsible for your team's data? If you're saying yes to many of these things, I think you're doing knowledge science work and not being a data scientist. So this is something that I'm actively pushing now with a couple of my colleagues, with Professor George Fletcher in Eindhoven and Paul Groth in Amsterdam. I highly recommend you and encourage you to go to this website that we have, knowledgescientist.org. We're trying to create a community about this, about people who realize that they're knowledge scientists, of academics and educators who realize that we need to go extend our data science programs to include more knowledge science work. I think, frankly, we are creating all these data science programs and we're not teaching folks how to go do data modeling. We're talking about, what does this thing mean? And we're not teaching people about logic and knowledge representation. These are kind of lost arts that they shouldn't be. So that's one of my main takeaways that I want you to have. So let's go into the processes a little bit. So I'm a computer scientist. I mean, UT Austin's a really hardcore theory and systems place. Never in my life I thought I was going to end up working in methodologies. And I realized early on that when I'm going off into industry, that the only way for me to be successful is if I figure out a way how to go work with humans, with users. And you needed to have a principled, methodical way to go do that. So we devised that kind of working with customers. We've devised this methodology, which is an agile pay-as-you-go approach. So the idea is that we want to go build these knowledge graphs that bridges these conceptualization gaps. So the first thing is understanding what success looks like. And this was clear to us that success is understanding the questions that people needed to go answer. So we wanted to go first, so have a list of business questions that we want to go answer first. And we can go prioritize them in different ways. And the first thing we want to go do is capture a lot of knowledge around that. That's the first step. And then after we understand that business question very well and where the data can come from, we're going to go represent all of that in what we call a knowledge report. And we're literally taking the same thing that we do in science, and we're going to have peer review processes. And people are going to go peer review what this knowledge report is. And then from there, if it passes, right, if it's acceptance, you go off and you're going to go implement this knowledge. And at that moment is when you start creating your target, creating the mappings from the source, generating your knowledge graph, validating the data. And the output of this second step is the knowledge graph. And again, at this point, people are validating. There's another set of peer review that occurs to make sure the data is actually useful. And once the data is ready to be used, it goes to that third step, which is I'm actually going to go access that knowledge and then go answer the question. And once I'm able to answer the question, that's how I know I've been successful. That's how I know that I've generated data that's actually valuable. So then you continue the cycle again and you say, well, let me go off to that next question. And the first thing you should ask is, can I answer that second question with the current data that I have? And if you can't, you realize, well, I'm missing this other piece of information, the other piece of knowledge. Well, all you do is that you just start extending that knowledge graph with more data, little by little, and you keep going through this process, this pay-as-you-go process. Down the line, you realize I'm going through questions 1, 2, and 3, but with the data that I've generated to answer questions 1, 2, and 3, I can answer questions 10, 11, 12, because I really have this well-defined data in this knowledge graph. You keep going through this iteration. So let me actually go into a little bit of the detail of each of these steps. And by the way, this was the last piece of work that we've done. This paper was presented at the Semantic Web Conference last year. Proud to say that we were nominated for Best Paper Award on this work. So in this first process that we do, we literally want to go understand this as the as-is process within an organization. the who, basically go through these who, what, where, when, whys. You can imagine this is the stuff that the knowledge scientist would be doing and working with the different consumers and producers of data. Then we're going to go in and start collect as much data, collect as much documentation as we can, right? How are people answering this question right now? If so, how are they doing that? Are they running queries? Do they have Excel, or their macros in Excel, or their ETL scripts? Let's go catalog all this information that we go have. And then once we do that, we realize that these things can be very this whole process can be hard, because look at this. We talk about what is an order, and this order is a concept in my target. And we say, well, let's start talking about what is an order. And when you start realizing and defining with the business users, you realize that here's my definition of an order. Okay, it's more detailed, but it's still English, right? It's still natural language. It's ambiguous. I want to go ground this in the data. And when you do that, that's how you start creating these mappings. And you start saying, okay, where is this in the data? And after working with the data producers, with your technical folks, you realize this is the particular SQL query that will return me the data that satisfies that definition that the business people are looking for. So here, what you have on the left, what is an order, that is going to be our target. And this thing here, this query, is going to be the connection, is going to be that mapping from source to target. Again, here's another one. What is the net sales of an order? Financially, we know that net sales means the gross minus the taxes, minus the discounts. But hey, in this particular definition, it's much more complicated. You got to know that there's currency involved and a lot of other things. So same thing, what does that actually mean? Well, you got to go figure out what is that right query to go access the data, and that's going to be my mapping. This is the type of stuff that is, you need humans involved. So I pause here and I say, how could we generate this automatically if my input is going to be just 2 schemas? I think that's why I believe this is an AI complete problem. We need to have humans involved in here. So when we start figuring all this information out, we go through that exercise, we start documenting that and representing this in this knowledge report. So for interest of time, I'm kind of going to gloss over this. I'll represent this knowledge report for a concept in the graph. Here's this knowledge report also for an attribute in the graph. So attributes can be applied to concepts or can be applied to relationships. So in this order net sales is applied to the concept called an order. And then here we can go talk about, oh, is this nullable or not? What is the data type? What's the cardinality? This helps you figure out the constraints and values of data later on. What are the relationships? Oh, an order has a status. How do I identify the orders and the statuses that they have? What's the cardinality that it should have? So at this moment, oh, and on the final point I want to make is, even though we're talking about graphs, I don't want to be pedantic about this. I'm not meaning, my goal is not to say that people are going to go learn graph databases and graph query languages and that's going to be the next thing. No, frankly, it's well understood that people like to consume data as tables. So we need to be able to understand how the end user wants to go consume their data. What we'll see in a bit, what I'm going to show you in a bit, is that the graph is just this really simple model that people can understand intuitively when it's all the data, but at the end when they want to go consume something and go do pivot tables and rolls up and down, they still want to have the tabular data. There's nothing wrong with that. So ask yourself is, how do end users want to go consume the data? So when you're going through this process, right, you have all these 3 different personas. The knowledge scientist is working with the data analyst to understand the questions, the key concepts. The knowledge scientist is working with the data engineer to understand where this is in the data. Obviously, disagreements will occur in practice. But you know what? Given that we have a clear focus, we have a clear success criteria, we can ask ourselves, is this discussion helping us to address the problem that we're going? If it's not, we can table that discussion for later. And the whole knowledge report is something that we've defined in a way that it should be understood by everyone. We literally will have kind of like board meetings where anybody can go in, a producer of data, consumer data, can read these things and and discuss them and understand them. And this knowledge reports are things that I'm not inventing this right now. This is extensive work that has been done throughout the 90s and all the knowledge engineering work that was done. And that's another different big talk about the history here. So at this point, you can stop, have your peer-reviewed session. If you find an issue, you go back. If all things looks good, you get 3 accepts, right? You can go forward and go implement your knowledge. And at this point, your knowledge report has all the work. And all you just go is you implement it. You say, okay, what is my schema? Let's go draw out my schema. I've defined it. How do I create the mappings? Well, I've defined the query for every single mapping in here. I can just go implement these mappings. I can then go execute these queries and go generate the data now in the graph. So there's usually 2 approaches that people go do this. In a materialized approach, you basically extract the relational data, you transform it to a graph, and then it gets loaded into a graph database. Or in a virtualized approach, you have a graph query, in this case, like a Sparkle query in terms of your knowledge graph schema, and then using the mappings, it gets translated into a SQL query down to the source, and then the results come back. In particular, my PhD thesis was all about this virtualization, this no ETL approach, and being able to understand how Sparkle can be, how existing relational database engines can be reused to do all the optimizations for Sparkle queries. So finally, you also want to be able to define these tabular views, and you start defining these graph queries that returns basically these tabular views, because this is what people want to go consume. And then there's different ways to go validate the data. This is a big, another different topic. Another different talk can just go on about how we go validate data. At this point, right, you go validate the data, and people realize, do we find issues? We go back into the implementation. Otherwise, let's go off and let's go access the data. Then finally, you say, well, let's go answer the business question. Now, up to this point, you should realize, wait, Juan, why do we have to go do this? If my whole goal is to answer a question, and if I could go do this in one database, why did I need to go create this knowledge graph? Valid question. But this goes back to the application-centric view of the world. If I'm going to go run this query over this application-centric view of the world, I'm writing queries in terms of database tables and columns that make no sense. But if I'm doing this in a data-centric approach, my queries make sense because they're connected to the mental model that the end users are thinking about. And this is the conceptualization gap. If we end up focusing always having to write queries in terms of this application-centric approach, we're always going to be bottlenecked by only people who understand the source data. We want to be able to have a higher level abstraction. And that's really it here. This null knowledge graphs is just giving us a higher level of abstraction. These mappings is a way of doing some sort of being a compiler. And I think for me, frankly, the way I summarize computer science is you decide in which level of abstraction you want to go work on, or in which type of compiler you want to go work on. And that's how people go define their careers within computer science. And then we go answer the business question, and then you can move this stuff to production, but I'll just, given time, I'll skip a lot of the details here. So to wrap up a little bit, let's talk about the tools. And I don't want to do a pitch here about what we do at Data.World and stuff, but I want to give you kind of this idea of this journey on this journey that we want to go through. I think first of all, within the enterprise, people don't know what data they have, and they want to go catalog the data and understand what data they have. And that's when this is where all this metadata management occurs. But once you have your tools that helps you manage your metadata, you got to go do something with it, right? I find the data, I need to go do something with it. At that stage, you want to go access your data. And this is when you start realizing, oh, I want to go access my data, but hey, I want to have virtualization technology, federation technology, because I don't want to go physically move things into a warehouse and stuff. But you're still accessing the data at the application-centric view. At that point, what we realize is that people say, wait, I don't understand my data. And that's why you want to go put this layer of knowledge on top. And people, honestly, what I'm seeing in practice is that they need to go through this, what I call this crawl, walk, and run step. They need to go do all the metadata cataloging first. They need to go start accessing their data second. And they need to start figuring out that pain that, wow, it's really hard to understand this. And at that point is when they realize, let's go put the knowledge. So what I realize in practice is that there are a lot of tools that do metadata management. There are a lot of tools that do just data management, virtualization, federation. There are a lot of tools that do knowledge and knowledge graphs. A lot of people are jumping to the knowledge graph part. I believe that for companies to be successful, you have to go through this crawl, walk, and run approach. Go metadata, data management, and then you realize you get into the knowledge management. Second thing, cloud is the future, period, right? I mean, we all saw the IPO of Snowflake. That's amazing, right? Imagine that 5 years ago. I remember at Sigma, I was in San Francisco when Snowflake was just starting to present. There was an industry paper of Snowflake. 5 years later, they're IPO'd. It's crazy to think that enterprises are trusting to go put their data in the cloud. Cloud is the future. And I tell everybody, if you're building a tool, make sure that you're already thinking about how to build your tool, your system for the cloud, and make it self-managed on the cloud. Not just let me go containerize this and put it in AWS. Like, you think about how you want to go self-manage this, just like Snowflake. It's a huge inspiration. So that's another thing to think about. Another thing about tools, we need to have collaborative tools. And I think now in this era of COVID is when we realize that we're not going to be together all the time. We need to have ways to go do this. And this is one of the tools that we did at my previous company, Capcenta, which is this visual, collaborative, real-time knowledge graph schema and mapping editing tool. So we took this idea of visual modeling and combine it with Google Docs, that you can really share documents with people. It's real time. So if I want to document, somebody else wants to document, they can see how things move. We keep track of history. We have commenting. You really need to have collaborative tools. And then you also need to understand your users. This is so, so important. When you're creating tools, understand who are your users. So just to wrap up here very quickly, kind of a quick case study to show you everything that I've gone through. So this is a customer we're working with. They had all the problems I was telling you originally, right? They created this data warehouse. People weren't using it. They were very skeptical about it. They were still going back to their old school approaches. And then, yeah, there's all this organizational knowledge hidden within Access databases, people getting different answers for the same question. So all the challenges I was talking about before. So they really needed to have this understandable, trusted view across all these different databases. And they really want to have these business intelligence tools consuming the trusted data. And the thing is that everything was being bottlenecked by a small amount of folks. So they really needed to go expand the user base of the data. And they needed to do this in an agile approach. They were not going to go spend another 6 months or a year to go do things. So what we started out doing is, this was early on when we started the company, was we basically almost made a bet with them and said, hey, let's go try to reverse engineer your most trusted report and try to understand what's going on there. And this is an example. This is when I was first exposed to a query that was like 10 pages long. And this query that was 10 pages long answered one particular question. When we reversed engineer that, understood all that knowledge that was in there, we created this knowledge graph that had 15 concepts and around 40 different attributes. And when the users realized that, they said they had no idea how much hidden knowledge was within that one report. And suddenly, with the knowledge that we basically discovered that was in that report, in that one SQL query, they could answer 10 more questions out of that immediately. So this is something that has been growing for so long. And here, so this is an example of what this knowledge graph should look like, right? And then we have all these mappings defined to their different databases. What I'm showing you here is a graph of how the knowledge graph schema grew. Yellow are the number of attributes, and blue and the gray underneath, right behind it, are the number of concepts and the relationships between them. And what we see here is that every time you see kind of an increase was a new database that was added to the whole knowledge graph. So what was interesting is that they had this requirement that they said, we need to go integrate 4 different databases. They didn't integrate the 4th database till month 21. And this is the whole point, is that when you start defining success in a different way towards the users, your requirements change completely and you realize, wait, I don't need to bring in that data later on. And then this was a clear message to us that you really want to be able to start defining, making sure that you're working towards defining the success. So to wrap up, I've talked about knowledge graphs here, how it's being used. And this term knowledge graph became very popular around 2012 with Google, but there is this large history behind it. There's almost, and with Professor Claudio Gutierrez from Chile, we have been looking at the history of this for the last 50 years. We have a paper that should be coming out next month in the Communications of the ACM that it's an overview of knowledge graphs. So I started this talk almost like 50 minutes ago or something with this question: how can we generate meaningful data from complex enterprise data? First of all, we need people. And I think the people we need is this role that I'm pushing called the knowledge scientist. And everything that I presented up to now, I agree, depends on this role. We need to have processes. We need to have agile pay-as-you-go methodologies. And there's things I haven't even talked about. What happens about if there's a maintenance? How do you deal with maintenance and evolution? How do you deal with the expressivity of the ontology being defined? Open questions, I have not touched this. We need to have cloud collaborative tools. And these tools need to be designed for the users and in conjunctions with the methodologies. I will acknowledge that everything I presented here is manual. And actually, that's just kind of my approach of doing science here. I want to understand this problem from the bare minimum, like my baseline. I'm being very, what's the baseline, which is doing everything manual. And then once I understand this baseline and I have different steps that have clear inputs and outputs, I can ask myself, can I now can I start automating this smaller problem that has a clear input and output? So a couple of different projects that we're looking at. I'm working with Professor Wynn Martins from Bayreuth in Germany on understanding query logs analysis, because there's a lot of stuff you can get from query logs. We want to be able to understand mappings from all these source queries. So it's a project I have with Marcelo Arenas. Nulls, so many issues with nulls. So what? That's a project I have with Leonid Lipkin. We actually have a big survey coming out for that. I think we posted that on Data.World. You may have seen that. I'm want to have projects on understanding how to deal with data quality and mappings. We have a project on data set search with Lehigh University. Another one, we're starting another project with Rafael Castro Fernandez at Chicago on metadata modeling. A lot of really interesting projects are coming out of this. And I have to say, Data.World is hiring, so take a look. And with that, thank you much for your time.
Okay, thank you, Juan. That was a huge whirlwind tour of the state of data and metadata management in the real world. That was very informative. We learned a lot of new stuff. Let's see if we can give you a round of applause virtually with Zoom. There we go. We have the applause button.
Well, thank you. Thank you.
That's the best we can do in this virtual environment, Juan. So at this point now, we can take a few questions. Anyone in the audience, if you have questions, raise your hand.
To do for another long time. I'm not mad at you. Look at it, try it. I have no time now.
I guess Aline has no time now.
No, sorry. I was telling my kids something exactly the time. I don't have time now.
So Aline and I will be joining you on for the meeting after this.
Perfect.
I think, let's see if the audience doesn't have a question. I have a question for you.
Yeah.
This talk is kind of reminding me of this famous quote of this software engineering professor, David Wheeler, where he says, all problems in computer science can be solved by another level of indirection, or something like that, right? In software engineering. And here, the way I understood what you're talking about is we want to build metadata for metadata that is recordable and easily understood when you're trying to do this sort of data integration, so that you can verify things rather than having to depend on people's word of mouth stuff. Would that, so what would that entail when someone is actually going about creating a database architecture for a company? Would they have to create not just the metadata, but also this knowledge report? And would the knowledge reports themselves be unambiguous, or will they suffer some of the problems that you talked about earlier with data integration?
So here's a big question, which is, could you goes, could we create applications that could directly think about, I'm trying to find the right slide. Could we create applications that if you had this schema, this model from the beginning would be sufficient? Or are there really specific requirements that it's going to make it impossible to go do that? And that's why we're going to end up having to go define schemas on this left-hand side. So when I'm rephrasing this kind of, I'm not answering your question on purpose, so apologies for that. I'm gonna kind of throw it back to you with a question, or question for everybody is, we have this application-centric view of the world and a data-centric view of the world. Is it possible to live in a world where we only have this data-centric view and we can forget about the application? Or is it inevitable and we're always going to have that? And if we're always going to have the application-centric view, then that means that we're going to have to have a higher level abstraction. Because if we don't, if we can go forward, be able to define things from this data-centric view, then yeah, we are in that higher level abstraction. We probably skip a level. Did that make sense, my commentary back to you?
Yes, I think that helps a bit. Yeah. One of the issues I realized with what you're calling the application-centric view here is that was really designed not during the data integration era, right? Like SQL came about in the 80s. Data integration really took off in the 90s. That's sort of what the history has been in the database community in terms of the amount of study that people have been doing. But as you pointed out, historically, knowledge representation field has been looking at this for a long time. So the application-centric view was not designed with data integration in mind.
No.
That might take.
It was designed for the application.
Yes.
It was that's it.
Yeah.
So,
okay.
So, yeah.
Yeah, go ahead.
No, back to you.
Right. So now that people are realizing that data integration is such a huge challenge, it might require, like you said, thinking at both levels, where you have the application-centric view if you're within a database that you're very familiar with, and this data-centric view when you have to link concepts across databases and across organizations.
So I always recommend people, there's two books I recommend people to look at. So Software Wasteland. So that's one book. This book, Software Wasteland, really describes the problems of this application-centric mindset. And then the author has a follow-up called the Data-Centric Revolution. Mm-hmm. I highly recommend these two books. And they're not academic scientific books, but I think you look at this stuff then you'll get ideas. So from a scientific point of view, this is what I encourage scientists, the academics, go make observations in the real world, and you're going to find your interesting problems that you're curious about. These two books really will open up a lot of great questions. I will guarantee you.
Mm-hmm. I got that book, The Software Wasteland. Very interesting. I started reading it. Okay, more questions from the audience.
I have a question, Aline, here. It wasn't clear to me how much of the methodology that you advocate you apply in your company. I mean, to customers.
Yeah, so we apply it all the time. I mean, that didn't come across here, but that's something we for anybody who's actually starting to create a knowledge graph, working with us, they go through this entire process. Now, I will say that this methodology, we applied it for kind of more on business intelligence or like reporting type of scenarios. Now, if you're going to build a general purpose knowledge graph like Wikidata, right, DBpedia, or you're building something for search like the Amazon product knowledge graph, this is not the methodology for it.
Right. But so I understand that if the customer already is leading towards building the knowledge graph, you can work with them. Has it ever happened that it never crossed their mind? They just wanted help with integration, and you convinced them to build a knowledge graph.
Mm-hmm. Oh, so you're asking me how do I convince people to
I'm asking you if you ever were in the situation and you ever convinced them. I'm not even asking how. I'm asking they did not set out to build a knowledge graph. They just set out to integrate.
Yeah.
And when they talked to you, you told them, well, the best way to integrate is via this knowledge graph.
Yeah, I mean, I think this is a longer conversation, and it's more of a business conversation than a technical one. But essentially, there's so many different aspects. I mean, we've had scenarios where people have just failed so many times with the current techniques that they're open to something new. I've seen that before, right? You have people who are younger and visionary, and they're open to the next new thing, and they believe that the traditional approach is not gonna work for me in 20 years, right? And they have a lot of personal capital they're investing within the organization, so they really want to go invest. They're going to bet their career on the next thing, so they want to go do that. And what you really struggle is with it's a generation issue. You struggle with the folks who frankly are between their 40s and 50 years old, who, oh, I've done this before and there's no reason why I need to go change. I'm probably going to retire in 5-10 years. Don't tell me something new. I just know how to go do my old thing. And yeah, so then you end up having conversations with, Aline, you probably had before, explaining why you want to go do a graph and why a graph is different than a relational database. Honestly, those are not the people will have those issues, and honestly, I don't spend time with those folks. I think I look for other folks who are more open to it. That's a very quick answer. That's more of a business answer with my business hat on. So
that's why I was asking, because I have noticed exactly it is a people problem among others.
Yeah, this is so here's the deal. The generations I'm seeing is the people who get it. Actually, folks like this guy, Dave McComb. He's 65, 70 years old. He gets it, but he's retired, right? So he understands it, but he has no decision-making power. Then you have people who are probably almost about to retire, between 5-10 years to retirement. They have no incentive to go take on a new project with new technology, go learn something new. You won't teach an old dog a new trick, right? So that's them. It's going to be so hard to go convince them. Then you have the next generation of folks who basically are the NoSQL data lake folks. They still can be convinced, but it's so hard because they've already drunk the Kool-Aid of the traditional. They grew up with big data 20 years ago with all this stuff, 15 years ago, right? So they're the ones who are right now in the position of power, of decision making, and all that stuff. And this is the majority of the world right now. One big part of the world. The other part of the people who are kind of about to retire, but they still have a lot of control. Now, I'm thinking literally 10, 15 years from now, the next generation, which are folks who are just coming out of school, and they're the ones who are going to be in decision power in the next 10 years. We need to get them very well educated. The risk right now is that they're all drinking the machine learning, deep learning Kool-Aid, and they all expect the world to go automatic. And I think that's something that we need to go make people understand, that the world is not going to be that easy. And part of me says that's why we need to go introduce the knowledge science, right? And make sure that we're having these types of conversation, of education, these different roles. So that's kind of the generational issue that I'm seeing. I don't know. I'd appreciate your insights, Aline, because I know that you're very much in the space too.
Well, yes, although my emphasis has not been on knowledge graph, but just graph databases in general. So for that reason, the space that I'm working in assumes that the customer has a pretty clear understanding of the concepts and how they are related to each other. And it becomes more a question of what logical data model do you want in order to talk about them, and what particular underlying technology do you want to talk about them, tabular or graph databases. And already there you find it that it's often the case that they agree that it's more natural to think about their data as a bunch of entities that are related by typically binary relationships, and therefore it's a graph. but there is all the legacy of the tabular based engines that they have already built on. Not to mention the ones, if you're talking data science, who have built on absolutely no engine, but on a bunch of spaghetti code Python scripts.
Yep.
And already there is a big battle just to convince them to try another engine.
So
in your case, you have the added obstacle of convincing them to just order their concepts.
So in our, I mean, if I talk, I'm pausing here because I acknowledge I'm putting my business hat on instead of the scientific one, but it's this journey that I'm showing you. That's how we approach the problem. So you start from very basic, understanding what data people have, and you try to solve that problem first, and then you let them go access to data, and then you solve them that problem, and so forth.
Mm-hmm.
Okay, we are running out of time, but I have one last question building up on that one, and also related to a point you made earlier. It is like in data science curricula that we are seeing is overemphasis on AI and ML and stats and stuff.
Mm-hmm.
Here at the HDSI, we've actually added a strong emphasis on the database and data management and systems components too. And another one we've added is a capstone project, like a year-long project for students to work in a real data setting. But one thing that we know as a challenge is enterprises are not forthcoming to do that sort of stuff and give access to their data to academia or students. Like this hundreds of tables schema that you showed, as far as I can tell, no database class in the world teaches that sort of stuff. Like, how do you deal with schemas at that scale? And that's true in computer science, let alone in data science. So how do we bridge that problem? I mean, education is also not just a technical issue, right? It's also a people problem. Do you have any thoughts on that? Should industry and academia partner more for capstones where they go get exposure to this sort of knowledge graph issues in actual enterprise settings?
That's a fantastic question, and I honestly don't have a good answer. I have an answer, but I don't think it's a good one. Which is, I am very lucky that I'm in a position where I can start establishing more types of research partnerships between us and academics, and like these types of ideas that we're seeing and I'm sharing with other people is because I have this opportunity to go work with others. I mean, as I mentioned at the beginning, Data.World is a B corporation, right? It isn't we have a public benefit. So I'm doing my little piece by trying to go work as much as I can, sharing as much as I can with the academics on what I see in the real world, and we can actually share some data. So with the partnerships that we have, we actually can share data and stuff like that. So my answer to you is, I hear you, and that's why I'm stepping up and doing something. And I wish more people could do the same. And honestly, I don't have a better answer more than that.
Okay, that's fair enough. I mean, it's great to see at least some subset of folks from industry recognizing this as a major gap between how we teach data integration and metadata management in academia versus what they actually face in the real world.
So I can tell you, based on some of our back and forth email conversations, I've started to have other conversations with folks from the database community who are in the industry. So we're going to see if we can get a tutorial into, I don't know, Sigma or VLDB, where we can just sit down and just share with you problems.
That would be great. Yep, love to have that. Okay, so that brings us to the end of the seminar. Let's all thank Juan. How do you pronounce your last name again?
So many different ways. Sequeda, or in Spanish, Sequeda, doesn't matter.
Okay, let's thank Juan Sequeda. It was great having you on, and thank you for joining us. And thank you to the audience for joining the seminar.
Great, thank you.
Take care.